Model of finding associative rules in inhomogeneous data of semantic networks. Product basket problem. Group products by department so that consumers can find them more easily. This reduces the time spent shopping in the store and makes a person interested in buying something else. Associative rules do not help identify the consumer's personal preferences, but they can help identify relationships between items in each purchase transaction, as opposed to filtering preferences. Data for the search for associative rules are considered separate purchases of different consumers by one group. The purpose of associative rules is to find all the relationships, also called associations, between elements in a data set, using certain patterns between the data. The basic concept of associative rules can be represented as follows: that S is a list of things, then T is a list of transactions, purchases. The concept of support value. The calculation of the support value rule is to represent transaction T, which is a subordinate union of x and y, where x and y are a set of things, and in some way is a probability P. In other words, is the amount or percentage of transactions that have a set of specific elements. Support value of the x is followed by y rule will be calculated by the formula 1, where n is the number of transactions in T list in our database, and support count is the number of transactions in T that include x and y. The concept of confidence value. The confidence value rule consists in represented transactions T with values from the list y which include x, and in some way is a conditional probability P. In other words, confidence value determines how often things in list y appear in transactions with things in list x. Confidence value rule x is followed by y will be calculated by the formula, where support count of x is the number of transactions in T that include x, and support count of union x and y is the number of transactions in T that include x and y. The concept of lift value. There is a problem. What to do when confidence value, for example, of rule item set of items A and F is followed by item set of item C, is less than P of C. Lift value acts as an indicator of the predictive power of the rule compared to a random event, calculated formula 3, where if lift value is greater than 1, then y will occur more likely at a given x, and if lift value is less than 1, y will occur less likely at a given x. Can be represented as if x and y are independent, the value of lift value will be equal to 1. If x and y occur more often than if they were independent, lift value is greater than 1. Semantic networks and search for associative rules. Scope and prospects of application. One of the areas of the application may be medicine. A considerable amount of semantic data is constantly generated here. In particular, most semi-structured and very heterogeneous data sources, for example laboratory test reports, ultrasound scans, images, are subjected to semantic annotation using a variety of ontologies. Traditional associative rule search algorithm Apriori. Here's an example. On the first stage we have a formation of one-element candidates. We have item sets and their calculated support value. Also, we said that minimum support value is equals to 3, so all the item set with support value less than 3 we cut off. So we have 4 item sets. After that, there is a formation of 2-element candidates. Then we again calculate the support value and drop item set with support value less than 3. We continue the iteration, and the result is item set of items A, B, C. Methodology. In figure, the method scheme is presented. The transaction maker can identify and construct transactions according to a defined mining scheme. That of received transactions is processed by a traditional mining algorithm, which finds associative rules at the minimum values of support value and confidence value. Methodology. To obtain entities and transactions, users must specify the target concept of the analysis and related functions. The features must be relevant to the target concept. For example, they will be extracted from the subgraph of each instance belonging to the target concept of the analysis. An algorithm to find associative rules in semantic networks is proposed. To the left we can see a grammar for associative rules search schemes, and to the right an example of it. Analysis of the results of the algorithm for finding associative rules in semantic networks. Here we can see tables with results. Results of experiments on the number of generated transactions and their average length, results of experiments on the number of generated transactions and their average length, the result of the impact of the application of the imposed restrictions in the search template. Analysis of the results of the algorithm to find associative rules in semantic networks. Transaction coverage, average confidence value of generated rules, and coverage multiplied by the average confidence value of transactions. Associative rules are found in semantic data. Considering the first rule as an example, in 100% of the transactions, a patient with oligoarthritic and lumbar pain has active tissue inflammation in this department. The greater the lift value, the greater the dependence of factors. For example, how much the presence of one element affects another. On the contrary, with low lift values, the softer it is, the greater the negative effect one factor has on another. When listening to the patient's lungs with a stethoscope, the doctor can better judge the presence of problems with them and better assess their general condition. Conclusions. Summarizing all the above, the research in this paper aimed to consider the basic concepts and find associative rules in both traditional ways and inhomogeneous data of semantic networks, which create specific problems when using existing algorithms. One of the most popular areas of application of the search for associative rules is still the consumer and marketing sphere. Semantic network data, in most cases, serve a specific area and are highly specialized. Perhaps that is why many exciting studies can be conducted in this direction, one of which is the search for associations among various heterogeneous data.